Hello everyone, in today's video I'm explaining about Baeyer-villiger oxidation. So we know already oxidation is nothing but addition of oxygens or removal of hydrogen. So now let us see the Baeyer-villiger oxidation reaction. So here acyclic ketones or cyclic ketones on reacting with a per-benzoic acid or per-acetic acid converts to esters or lactones. So you can observe here ketone is converting into ester. Here there is an introduction of oxygen taking place. So it is the oxidation process. Okay. Next you can observe this cyclopentanone. Cyclopentanone is a cyclic ketone. Here you can observe there is an introduction of oxygen beside this carbonyl group is taking place. So cyclopentanone is converting into lactone. Whenever we are taking the cyclic ketones, they converts to lactones. So here let us see the mechanism of the reaction. So ketone, first I am taking the ketone. Ketone, you can observe oxygen is having a lone pair of electrons. So they undergo, this ketones undergoes protonation in the first step. Protonation, this proton is from per-benzoic acid. So you can observe this lone pair is attracting the proton and forming OH bond. Okay, so as oxygen is donating electrons, it is getting the positive charge. So next what I will do, in order to nullify this positive charge, I am shifting this double bond towards oxygen. So next this positive charge will be nullified. This carbon gets the positive charge. This positive charge is nullified and this carbon is getting the positive charge. So next step I am adding the per-benzoic acid to the carbocation. So whenever I am adding per-benzoic acid, it can break into H plus and per-benzoate ion. So this per-benzoate ion, this you can observe I am shifting the bond towards oxygen. This O minus will be there, no? This O minus part, C6H5CO, OO minus part is attacking on this positive charge and forming, you can observe I am writing this R down here, and it is this carbon is forming OO linkage along with this CO C6H5. So next what I will do, I am breaking this OO linkage. I am shifting this bond towards that side. So this part comes out. C6H5 COO minus comes out. So next what I will do, I am breaking this bond. I am shifting this bond electrons towards R. R gets negative charge. This negatively charged R is attacking on this oxygen and forming OR bond. This carbon is getting the positive charge. Okay, next in order to nullify this positive charge, I'm donating, this oxygen is donating electrons towards the carbon and forming a double bond. You can observe this lone pair, this positive charge reacting with each other and forming a double bond. So now as oxygen donated electrons, it gets the positive charge now. This oxygen donated now, it gets the positive charge. So next in order to nullify this positive charge, I am shifting this bond towards oxygen. Okay, when I am shifting this bond towards oxygen, this hydrogen comes out in the form of H plus ion and this positive charge is nullified. Finally, you got RCOOR, that is ester as a product. Okay, so ketones are converting into esters, okay, through the Baeyer-villiger oxidation process. So this is about this oxidation reaction. So practice in order to remember the reaction more easily. Thank you so much for watching.
Order of migration groups: 3-degree alkyl cyclohexyl, secondary alkyl benzyl phenyl, primary alkyl methyl hydrogen. Example: this example, two possibilities there. One, this bond breaking, in this bond breaking. Why in this only consider means cyclohexyl and primary alkyl migration. Cyclohexyl more migration. That's why form to the, this is the product. This is the major product. Key point: insertion of oxygen takes place. What is the main reaction? Ketone in the presence of per acid or peroxy acid to form a ester.